So, brief history of what happened from what the customer told me and from what I went before when I had the vehicle. But just briefly, the car, the manufacturer did replace the timing chain. Honda did. They flushed it on multiple occasions. They also cleaned the intake. I'm sorry. They cleaned the cylinder head, the upper portion of it. I'm not sure how far in depth they did, but when I pulled the valve cover off, it was obvious that somebody went through and cleaned it. It did have some new parts on their timing chain. When I got the vehicle in my possession, I did check the wiring circuit, but I'm gonna go back and check all that stuff. It's out of focus. And hopefully narrow down what's going on with this vehicle, and hopefully I shouldn't have to get to the point where I gotta use a scope or anything, because I was gonna check the see if I can manage to see if I can see the cam gear varying, but there's no sensor on the front of that gear there, which I could probably compare with. But I don't know. I'm gonna figure something out and go by step, see if we can narrow this problem down and make a little man like me seem bigger than a larger entity like the dealership would be, right? All right, let's see what happens. First off, I'm gonna try to get the code to manifest again. I'm gonna take it for a drive. The drive cycle specifies that you basically just get the car to about 30 plus miles an hour for about 10 minutes. If there's an issue, to coast the surface. I guess that's when it goes through its diagnosing or monitoring phase for that sensor there. Or so I don't know. We'll see. I'm gonna go through that drive cycle first and see if I can get the code to surface, which should come back up and go from there. All right, about 5 minutes later. Well, trust me, there's that P code, that P0010 code popped up, so I might need to change the way this thing focus. So that's what we got coming back up. I'm gonna look at the code setting conditions and maybe there's theory of operation. Go from there and narrow down what the problem is and see if we can solve it. It's trying to stall right now. That's what it's trying to do, but we'll see. So I'm gonna check the circuit first. Make sure I got some resistance value going through the worm. Show you how that look. Keep this steady. All right, the PCM resides behind the glove box. This is where I am. This is the HVAC system. The pin at the very bottom, the connector, the second. So it's A, B. It's gonna be the second one from the top. Second one from the bottom. It's gonna be this connector here. I'm gonna turn it forward, and here I've marked. This is life, right? The lights are going off. Here's the female end of the connector. If you can see it well, I've marked the spots with black magic marker last time, but I'm gonna show you on a computer where they're supposed to be. This is it right here. This is the connector. What I did was I'm gonna check the ohms going to I'm gonna reconnect it and check the ohms going to the solenoid. What I did currently was put my jump box to it. I have it disconnected from the computer. I sent 12 volts to that connector where I assumed that was had a broken wire. I put a pin in the back of it. It was the blue and white wire. That's the wire that sends power. So taking the pin, back probed it, put an alligator clip on it, sent 12 volts through there, and I do have 12 volts going through there, so that's a good connection. The ground is good. What I'm going to check next is the resistance value from this going to the solenoid and make sure I got resistance value that's in specification, which is the, let me see here, 6.8, what? Where is it at? down here somewhere. I have to edit this out. Where's it at? There you go. 6.75 to 8.25. So measure resistance between the oil control valve, solenoid, terminal 2P, and terminal 1, and number 1. So that's the strangest thing though, I didn't get any type of resistance when I did. Alright, hold on 1 second. Okay, I had to change some equipment. The ohm meter I used was a cheaper ohm meter, and I was getting improper ohm readings. It was saying like 2 ohms and like 0.02 ohms. I mean, on a 20 scale, and I'm like, this ain't right. You know, this. Anyway, I used my Fluke ohm meter, and I got the resistance value that the manufacturer specified. What it was when I connected to, when you connect the ohm meter to the solenoid, you're supposed to get like around about 6.7 to 8.25 reading. Just literally, I forgot. But I got a oil control valve pulled out of another car when I did a motor a long time ago. I put the multimeter here on the pins, and I did get this one within specification. I can't remember what I was reading it. Hold on, let me. All right, so I got this one hooked up. This is the one that was out of another car, and this is reading 7.4 ohms. The one in the car here is reading at 8.8, and that is out of specifications per Identifix here. Let me see, right down yonder. Yeah, so it's supposed to be at 8.25. So I'm gonna swap this one out with the used one, so I wouldn't be shooting apart at it. And I know it's in specification, and check for this. Check in the light, see what happens. And I'm pretty sure there's some variances with the wiring resistance, being that the wire also can alter the resistance value. So, but I'm gonna put something in there that's known. Well, it's known that this I can confirm is lower, and recheck the conditions. But I do recall a P0010 coming up on here as far as the oil control valve. Mind you, what I did do, I just have a wire sitting here. I did jump this wire off with 12 volts. It did change idle and stall. That is an indication that it is working, but you know, for some strange reason, it's still causing a fault. But I'm gonna swap it out and see what happens and get back. What's going on? All right, there's a change of plans. Thinking about it, okay. Let me get back to this. So I did check the resistance value of the current sensor in there, and I didn't add before that it was already replaced. Where is it at? It's back here somewhere. There we go. So it was already replaced, and I didn't take consideration. I will add by the specifications, by the manufacturer's recommendation, well, standards of checking this with the multimeter. It does have to be at a specific temperature. That's why this one was in spec and this one wasn't. But I'm like, okay, yes, this car the engine was ran. I put brake cleaner on to try to lower the temperature. Now what happened was, as I left it on there, the resistance value started to drop, and I don't want to beat a dead horse. So it works. It's obvious it works. I'm probably just overthinking it, thinking like, hey, if the resistance value high, then therefore it's not going to be working properly. So I'm going to throw this back in there because, like I said, when I activate it, it won't stall, which is a good thing. I took my inspection camera here and looked through the oil passages. They are clean. I'm not going to rush to judge. I'm like, oh yeah, it's this, and this. But I really do think that I'm gonna have to take this valve cover off, make sure that timing the VTC gear was installed properly, because if it wasn't, and it's just, I don't know. Well, you know, I don't come to think about it. I'm just honestly just thinking out loud. So it's stuck. I tell you what, I already got the pins hooked up. I'm gonna hook the scope up to it and see what exactly has happened with the scope first, before I pull this off, since the pins are just literally right there and the computer's in the car. Hook this back up, hook the scope up, drive it, and go from there. So I'll get back with you. All right, so I didn't get any footage of the golly, I can't think of it. I didn't get the scope. There we go. I didn't get video footage of that. It was working fine. It would come in and then it would just fall out, and the system would just deactivate. Nothing. It's getting power, so I'm not gonna worry about the source, because evidently it's sending power to the computer. Evidently it's just detecting the fault. So what I found out was the camshaft, this bearing gear here is stuck. So what you're supposed to be able to do is hold the timing chain, and I just took a pair of vice grips, very easy. I didn't compromise the chain or anything, just enough just to hold it, and try to rotate the camshaft and see if it'll move, and it would not. So this gear is just defective. I mean, it has the recipe for a fully functioning VTC system, but it's not. You get power, the actuator is working with that solenoid. I'm sorry. You got power, good wiring, the solenoid is working properly. For some strange reason, it's just wanting to stall, and evidently if this cam gear can't vary like it's supposed to, then it's just stuck in the position. I guess it's just stuck in advanced position. So I'm gonna recommend the customer replace this gear here, and I'll just get back with the people after this gear is replaced. Labor time on this is 3.5 hours in the book. I'm gonna go through all that. I'm just gonna throw this joker on, and well, if they're okay with it, and go from there. I'll update later. Okay, gosh, I have fixed a vehicle that the dealership couldn't repair. All right, so this is what you know. What I'll give you the long drawn out story. Well, in 60 seconds, I'll try. So, I replaced the VTC gear with no avail. Got back in the car and started up, and I got it jacked up. I'm not going to drive the car to set the monitor conditions to get the check-in light pop on. Just jack it up. You could press the gas pedal up to about 2,000 RPM, and the check engine light would come on because of the P0010 code. All right, so I fixed the car. I'm going to tell you exactly what to look for. It's a very simple circuit. I think I was beating a dead horse. The information that you will look at will recommend that you check the wiring, which I did. Check the continuity of the wiring, check the grounding, check the computer. You can check all that, but guess what? You're going to get everything that's in specification. This is what I did. You don't have to replace you know what? Check the solenoid, make sure that's just within specification, the 6.75 to 8.25 ohms. I think I described it earlier, but it got to the point where I pulled down the oil pan. This is what will be on 6 seconds now. I pulled down the oil pan. I checked the pickup. I checked it for any obstructions down there. Put it back. That was not fun, really. Redid the timing chain, put the VTC gear on, put the scope to it. I'm just checking everything. I'm checking the cam sensors and stuff like that. I mean, just making sure the cam is got a decent wave. I was kind of desperate, so it got to the point where, you know what, I'm like thinking rationally. Now, what you want to look at, the VTC duty cycle right here, VTC solenoid duty cycle. This is supposed to be below 40%. If this is not below 40% and above for, let's say, within 5 seconds or something like that, it's going to cause that check engine light to come on. Now, my thing is like, well, if there's a fault with the sensor, I can understand that getting bad information to the computer, but there will be drivability problems. Long story short, I'm like, it has to be a PCM issue. Nothing else is going to tell this sensor what to do besides a PCM. Okay, even though it's sending signal out, you're getting voltage, it shouldn't be doing what it's supposed to be doing. The thing is, even when I scoped this, it went up to 12 volts, 13 volts. So it would go up to 100%. Look at this PID here with the bidirectional scan tool. Look at the VTC duty. Let me just pull that up by itself. Oh my gosh, I am like excited, and at the same time, I'm just mentally debilitated. All right, so look at this. Look at this duty cycle for the solenoid, and it should be below 40% and fluctuating. The computer should be in complete control of it. It should not go to 100%. I'm not going to put this old computer back in there because I had to program the key, and I don't feel like having. I don't know if it. I'm pretty sure that bin is still. I'm not going through that. It's in there. It's fixed. I'm buttoning everything back up, and people are getting their car. Anyway, so look at this PID. Raise the RPM to about 2,000. Ensure that the PID stays around 40%. Make sure it don't stay around. Make sure it doesn't go up to 60 or anything above 40 for for about 5 seconds. Like I said, what happened before was that the computer would automatically go to 100%. And I will tell you this, I mean, hell, I don't know what to say, man. But let me put it this way: if you don't have, if this is 100%, and you're getting P0010, go for the computer. It's like, fuck it, go for the computer. Put a computer in there, program it, do what you gotta do, call it a day. Because I mean, like I said, there's nothing else that's going to cause this. I don't think it's necessary to. I got to the point where I was thinking maybe the resistance value is what programmed, which is what determined the duty cycle. Maybe the resistance value of the sensor is what control the duty cycle. I was like, man, like baffled. But I'm like, how in the world could the resistance do anything when the resistance is going to alter the duty cycle? Is going to, I don't know. All right, I got desperate, and you know what? Then I had to go back to just logic. The computer only tells parts what to do. So, but yeah, to simplify things, check the resistance of the wiring. Make sure there's some resistance, and make sure there's low resistance in the wire, so your connection, your wiring from the PCM to the sensor is proper. Check the resistance value to the solenoid. Make sure that's proper. Activate the solenoid when the car is running. So take a jumper wire and activate the solenoid. Make sure that's working properly. If all that's working, and you can go to your tool, see the duty cycle, and this above 40% for about 5 seconds, then you know, like, there's going to be a problem with the PCM. Because, like I said, this one, these exact symptoms, it would automatically go to 100%. Look at the scope. It would automatically go to 14 volts, whatever the car was outputting. So it had no means of taking the inputs and interpreting to determine what the oil control valve is supposed to do. So, but yeah, I'm gonna put this at the last of my video, and at least y'all can see what the hell I went through as far as my speculation. This is a 2003 Honda CR-V, and I guess I'm gonna put this in the books as one of those confirmed fixes that the dealership can fix. Yay me, right? Alright, so no check engine light, everything's working perfectly smooth. I got the computer in there, got the key I got the immobilizer program, and I will say if you do have the MS906BT, you can program the 2003 Honda CRV computers. What else I want to add? I will show you the PID while I'm driving, what it looks like for the. Let's see if we can get a close up. This is a normal operating PID for the VTC, the oil control unit. So if it's not dancing around like that and it's just stuck on 100%, change the computer. A lesson learned. Gosh, what didn't I learn? I will admit, I did take the VTC actuator off for visual inspection, and it was locked in place, but I assume it was only locked because the solenoid would not supply enough pulse width, the normal pulse width, to be able for it to go back into normal position. That's just my assumption based on how it works. I'm pretty sure it has some to send fluid there to lock it in place, and then some to put it back in the opposite direction. And that's the whole means of the pulse width. I mean, if it's going to fully 100%, then it's only going to completely lock up. But what I would recommend anybody, if they have to go through it, check the wiring connection first. Check the solenoid. The resistance value evidently will have some truth value to it. Make sure those wires have low resistance that's going to the PCM. And I wouldn't recommend. They say you're supposed to ground the PCM, not ground it, but do a resistance check from the PCM, if I recall properly. But what I would do is just look at the PID, because if you have, it's a very simple circuit, and I hate that I even complicated it myself by checking timing, checking all this irrelevant stuff. But as far as that code go, the P0010, check that, look at the PID, make sure it's not fully 100%. If it's fluctuating, dancing like it's doing now, then you don't decide to put the oscilloscope to it and look at it. I mean, you still got the best of both worlds. So if you don't have the oscilloscope, if you do have the oscilloscope, you should be able to see the pulse width at normal operation. So you wouldn't see it just climb up like I was looking at, and it stayed at for 13 volts. I'm pretty sure the voltage will bear to where it would show this percentage. It wouldn't just be at 100%. So I'll edit a video to where I'm not going to cover up my mistakes. So I did take it off. If I got to remove it to visually inspect it, hell, I might as well just go ahead and change it. So, but this is a confirmed fixed vehicle. This is good. I repaired something that took many of mechanics, and this is a thankless job. So yeah, check those things out, and hopefully somebody else will not go through the same issue as I did, and hopefully take in consideration those few steps that I mentioned. Scanner Danner did have something up there, but it wasn't a Honda. But as simple as this circuit is, again, just check the wiring. Make sure there's no broke wires from the PCM to the solenoid. Check the solenoid resistance, and I'm pretty sure I had that in my earlier video. The values for that is supposed to be 6.75 ohms to 8.25, if I recall properly. Also, connect 12 volts to the blue and white wire while the vehicle's running. You see if it's trying to stall out or anything, at least you know it's functioning. And then look at this PID. Make sure this PID is fluctuating like I just showed you. Also, I didn't mention in my previous video, but the ground wire is between the ground wire that works for this unit. The VTC unit is going to be between injector 2 and 3 on the fuel rail. So make sure if you don't have a ground, and check that ground, because that ground supply is what works for this unit. All right.